Hey guys, welcome back. This is going to be the second update video for the Gumball Everything machine. For those just tuning in, I recently started working on a desktop machine that I hope, with the help of 3D printing, will be able to convert into any machine a hobbyist might need or want. So far, it can convert into a lathe, a bench polisher or grinder, a micromotor or flex shaft, drill press, a wet saw, both a flat lap and a split lap, a cabbing machine, a scroll saw, just to name a few. My goal is for the machine to eventually be able to do almost everything. Since the last video, I've made quite a few attachments, so I thought I'd show you guys where we're at with the machine. The first new attachment is this handle. The old machine had sort of like a stand that gets screwed on here. Now there's a handle, so it's portable, and the handle now doubles as what the previous stand did. So you can reposition the handle to allow the machine to stand upright, to stand on its side. Another thing that I've finished since the last video is the cabbing machine attachment. What I'm using for the cabbing machine are these 3D printed wheels. These are 100mm wheels that I'm covering in adhesive back sandpaper. And you can print as many of these as you want, cover them in sandpaper in different grits, and that would create your entire set of grits for cabbing on the machine. That's the cheapest option. If you want to spend a little bit of money and you want something a little bit better, the cabbing attachment, and I'll put it together in a minute to show you how it works, but the cabbing machine attachment is made to fit 100mm Nova wheels, which are basically the same size as these. So if you want to spend a little bit of money, I think they're about $70 each. To me, that's a little pricey, so I am trying to make it the cheapest possible way for making cabochons. But if you want to spend a little bit of money and you want diamond wheels, you can absolutely buy Nova wheels and they'll fit this machine. You just need to buy 100mm resin bonded Nova wheels. But we're gonna do the cheapo way. We're gonna use these. This is ceramic sandpaper, and it's 2 3/4 inch wide, adhesive backed. And like I said, you can buy it on Amazon, whatever grits you want, and you sand the surface of your 3D print a little bit, so there's a little bit of grip to it, and then you stick the sandpaper on here. Let's put the cabbing machine together and I'll make a cabochon, I guess, to show you guys how it works. Before I put together the cabbing machine, I need to cut some material, so I thought I would do the whole process start to finish to show you guys that you can use one machine to do everything. So I'm gonna first put the wet saw attachment on, I'm gonna cut my material, and then we'll turn it into a cabochon. And there's something that I didn't mention in the previous video about the wet saw attachment that I want to mention now. Some of you guys who are printing this might have noticed that the top has a little bit of play in it when you put it on. That's intentional. What you're supposed to do is wrap the inside here with a rubber band. And what that does is it acts as sort of a gasket to keep any water from splashing out. And now when you put the top on, it's nice and tight with no play. I forgot to mention that in the last video, so I just wanted to mention that now. So let's get the wet saw attachment on. We'll cut some material, and then we'll cab it up. Alright, got this cabbed up, ready to go. I think this is yellow jasper. We're going to just round the edge and then we'll try cabbing it. Alright, that's the first pass, so let's change wheels to a finer grit. Alright, I swapped it out for a 400 grit. I'm going to smooth it out a little more, and then I want to try something else. Alright, so I'm done with this grit, and I can put another grit on here and keep going, but there's something I wanted to try. Instead of using these sandpaper wheels, I had an idea that I just wanted to see if it worked. So everything here is printed with PLA, but I printed this with ABS, sort of to act as a trial. And the reason why I used ABS is because ABS dissolves with acetone. So what I was thinking is that I could roll this in acetone so it softens the surface, and then I can roll it into an abrasive like diamond powder or silicon carbide, and then let it dry. And theoretically, it should embed the silicon carbide or diamond into the surface and turn this into an abrasive that I could use to finish off the stone. So this is 400. I was thinking I would roll this in 600 or 800 grit and see if it works. Because if it works, that's sort of amazing, because what I could do is finish it with 800 and then wipe off the abrasive with acetone and then reapply a new abrasive, you know, and then so you could do theoretically, if you wanted to, you could do the whole stone all grits with just one wheel, if it works. And if you're using silicon carbide, it's very cheap, so just to dust this for each use would be really no big deal. Let's try it. I want to see if it works. All right, so I'm just going to dump this in the acetone. Just maybe leave it there for, I don't know, maybe a minute, 2 minutes. I think the longer you leave it in here, the softer it'll get. So what I like about this method is if this works, you could 3D print custom shaped abrasive wheels for doing, specialty jobs. Yeah, that feels like it's soft already. I'm gonna put the abrasive on now. This is what I'm using. I'm using 600 grit silicon carbide. I don't think this would work with a really large grit. I don't think the ABS is strong enough to hold the individual grains if they're really big. But I really don't see why this won't work for, I don't know, maybe 400 grit and smaller. It definitely seems like it's going to work for this 600 grit. You know what? I don't know why I did this. I should have put it on the machine and applied the acetone and the abrasive while it was running. That would have been so much easier. Just with like a paintbrush or something. Anyway, let's try it. So yeah, that's 400 grit, and this actually works a lot better than I expected. I could wipe this off, put a finer grit on here, and finish the stone on here, but I don't think I'm going to do that. I think I'm going to switch it into the flat lap configuration and put a felt or leather wheel and just finish this real quick with diamond paste. I just wanted to show you guys that you can make a cab from start to finish with just this machine only. And then I'll show you the next attachment that I made this week. This is a new 3D print too. This is a master lap. I wanted to see if a 3D printed one would work instead of having to buy a metal one, and it seems to work just fine. I have a diamond plate on here now, but I'm gonna put, I think I'm gonna put a leather wheel on here just so I could do the final polish. All right, I couldn't find my leather wheel, so I'm just gonna use this felt wheel. Just put a little bit of diamond paste on here just to finish off this stone, and then we'll move on to the next attachment. Alright, that's where we're at so far. I can obviously get a better polish on there, but I don't want to waste any more time on this. I just wanted to show you guys that it's possible. So let's move on to the next attachment. The next attachment is a router table that also doubles as a diamond glass edge grinder. It does a few things actually. Let me show you how that works. The spindle motor has 4 threaded holes here. That's where the router adapter is going to attach. There's 4 holes here if you want to put 4 bolts in. I find that it's fine with just 2. For now, we're going to use it as a glass edge grinder. So I have a diamond tool in here. So now the table adapter just slides right into there. And there's a screw on the side here for adjusting the height that you want. And these center inserts are interchangeable. So if you want to put a bigger or smaller tool in here, you can pop this centerpiece out and replace it with a bigger one. If you want to put like a big router bit in there, for example. But we're going to use it for an edge grinder. So I'm going to lift the table into position, and then you tighten the hand screw here. And now it should be ready to go. You can use it to clean up glass edges. You can attach a sponge onto here if you want to keep the tool wet. And what I like about this is you can, if you want to make any special guides or jigs or something, you can just drill right into this table, and if you destroy it, you can just reprint another table. You can shape little pieces of lapidary material on here. Shape metal. So this is useful. You can also use it as a router. Here I have a Dremel router bit. It rounds the edge. There's all different Dremel router bits, different shapes, and here's a slotting bit. You can put slots in wood. Take a metal bit for cutting sheet metal. Alright, so the next attachment is the scroll saw attachment. I tried to make this as easy as possible, so I'm trying to get it to work where it's entirely 3D printed, so you don't have to buy anything. The only thing you're going to need is this spring here, and like you saw in a previous video, you can make springs with this machine, so you should be able to make this spring if you can't find it. But everything else is going to be 3D printed except the blade, obviously. And this is an exciting project because this is the first attachment for the machine that's going to be reciprocating, which, if it works, it opens up the doors to a whole bunch of really cool conversions we can do for the machine. All right, now this one comes with a disclaimer. Because it's 3D printed, I'm not 100% convinced that these two parts are going to last. This Scotch yoke down here and the spring piston. I printed it out of PLA Plus, but I'm really not sure. There's a lot of force on these two parts, so I'm really skeptical if it's going to last for a long time. It'll probably work for occasional use, but if you plan on any heavy use with this saw, I would experiment with something stronger, at least for these two parts. The rest of the body I think is fine in PLA, but these two parts, I ordered some polycarbonate and some carbon fiber filled nylon that are supposed to be a lot stronger. And I'm going to print these two parts and experiment with that. So I'm going to release these files, but just keep in mind that there's a disclaimer that if you're going to use PLA Plus, these parts might break, these two top parts. You might have to experiment a bit. But let's get it on the machine and I'll show you how it works. All right, first you insert this part into the collet. I think it's the 9mm attachment that this slides into. And then you're gonna put a little bit of grease on here. This is what feeds the Scotch yoke. All right, this is gonna be what it looks like when it's on the machine. It gets attached with two, I think, M4 bolts in the first two holes of the 3 threaded inserts on the top of the spindle mount. We're gonna tighten these down. We're gonna grease this top spring up here. And we're going to grease the Scotch yoke underneath here. And then it's pretty much ready to go. There's just one thing that I want to show you. These are the 3 mechanism parts as they come off the 3D printer. Before you insert them into the machine, you're going to want to sand this perfectly smooth. You're going to want to grease it up. And then there's a little V shape here that this is where the blade attaches to, over here and over here. It's very fine resolution and it's difficult to get this perfectly on an FDM printer. So what you need to do after the part comes off the machine, I'm using this, you could use a cutoff wheel or a diamond wheel just to open up this slot here and then open up this slot here just to get rid of any stringing or any support material that might be in there. You got to do that to that piece and this piece, And then also you gotta, with a drill bit or something, you need to clean out the inside of this hole so it's nicely, perfectly smooth. All right, let's try cutting some wood first. Okay, so it can cut wood, no problem. What about metal? Here I'm cutting a really thick piece of aluminum. It's probably too thick. This piece is like 3 millimeters. It works, but considering the parts are printed in only PLA+, I'm going to say it's too thick. Maybe when I test polycarbonate or carbon fiber nylon, but for now, stick to wood and thin sheet metal and I think it'll be okay. And the final file I finished this week was this tool holder. I redid the previous tool holder, I made it slightly larger, now it holds more bits. It can accept both 2.35 millimeter as well as standard 1/8 inch Dremel bits. This file is going to be getting mailed out to backers this week as well. Alright, so that's going to do it. I have some fun conversions planned for this week. I'm going to be attempting to create a diamond ring saw conversion. I'm going to finish the tumbler attachment, and I'm playing around with trying to create a magnetic polisher conversion. So, if you're interested in this sort of stuff, please consider subscribing. And if you want to build your own gumball, I'm asking for a minimum donation of $10. For this, you'll receive all available 3D files, you'll be added to the mailing list to receive all future files and upgrades, and there's going to be a lot. I'm trying to shoot for at least one new conversion a week. You'll get a complete parts and suppliers list, a build tutorial. You can find all the info in the video description. Alright guys, that's going to do it. I'll see you in the next video.